So,
Doesn't matter who it was.
we are
And
going
Sam's
to
supposed to be on horse.
talk about sequences and series. It is kind of a short unit, and I debated on whether putting it in the beginning or putting it at the end of the semester, and I figured we'd just start off with kind of a short, easy one.
Yes.
So,
That's true.
and then we will probably spend, and then that way for the rest of the semester, we're going to take our time and we're going to work trig and angles and unit circle and all of those good things. So we're going to we're gonna do this one, and then that's when we're gonna start focusing on the trig, and we'll be on trig for a while after that. So
Oh my gosh, we
Geometry
just
type
next
trig?
Did you
week.
say that
Like
that's pretty
geometry type
difficult?
trig, or are we getting more advanced?
Because it sounds kind of difficult.
Wait till New Year's.
Eh. I would say just don't psych yourself out about it.
I had
Is
a
it like
dream.
geometry type trig, or is it hard?
A little bit, like the Sogotoa.
Okay, that's easy.
A little bit.
Oh.
Yes.
I mean,
Yes, you'll see when we get there. It's fine.
What's you
Yeah.
sus?
All right, that's not y'all.
Oh, okay.
So for our introduction to sequences, I promise you, it's really, really easy. Sequences and series can get complicated. We are not going to make them complicated because this is the first time that we see them. All right, but it can get complicated. So when you take like calculus, I can't remember 2 or 3 maybe, you do sequences and series, and it will get more complicated there. But this is kind of like the beginning of learning it. So we're not gonna get into the really, really difficult stuff. When you think of a sequence of events, you likely would consider what happened first, second, and so on. In math, the word sequence is also used in the same way. Some list of numbers have a first element, a second element, a third element, and so on. So it does kind of follow along the function pattern. So you know how you have functions and you have x's and you have y's, and the y's are like your list of numbers. It kind of is like that. One famous sequence that is found throughout nature is the Fibonacci sequence. And so this right here is the Fibonacci sequence. And the way that the numbers work is you start with 1. Well, 1 plus nothing is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. Do you see what I'm saying? And so on and so forth. So you're adding it with the previous term. So what that looks like as a picture is, if you look here, you start with 1. So 1 plus nothing is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. Do y'all see it? And then the shape here, these are squares.
Yes.
So this would be like an 8 by 8. And so then 8 plus, this is a length of 5. So this length is 13, which makes this length 13. And then 13 plus, this is an 8 with 21, which would make this 21. And then it goes on and so on and so forth. And you see this little pattern here in nature a lot, which is why the Fibonacci sequence is a famous sequence. And so a couple things that, I don't know, I just looked up pictures online, but one of the pictures I don't have here is seashells. So a lot of times when you go to the beach, you see the little seashells that have little swirls. It's a Fibonacci sequence. I don't know why it created, if you look at the little horns on rams, it kind of is in the shape of the Fibonacci sequence. So you kind of just start.
In the very middle.
This, it's a peacock.
Oh, I thought it was.
Yeah, it's a peacock. Those are the little markings on a tiger, maybe? I don't know. Your brain and ear, which is a weird thing. Scorpion hands, someone doing yoga. What is this? I don't remember what this is.
That looks like a flower.
It does look
Or like a succulent.
Oh, it is. Yep, I think you're right. And I think that's a bee.
I hate these.
All right, so anyways, the Fibonacci sequence is one of the more famous sequences, and it's just because it is found in nature. So it's kind of like a natural sequence that happens. All righty. A definition of a sequence. So an infinite sequence is a function whose domain is a set of positive integers. The function values are the terms of the sequence. So infinite will go on forever. Your domain is all of the positive integers. It could be any of the positive integers. So you'll see the little ... representing that it will go on forever. if your domain consists of certain n positive integers only, so we have a specific set of integers, the sequence is called finite. So if it ends, it's a finite sequence. If it goes on forever, it's infinite. Sequences can also be defined using recursion formulas. So you have two different kinds of sequences. You have what I would say like the regular sequence, which looks like this, where it has the variable n in it. And then you have the recursion formulas, which has a n minus 1. All right, so they're both sequences. This is the recursion formula, and then these guys are the regular formulas. So with recursion formulas, the rule will reference the previous term. And that's where the a n minus 1 comes from. So that's referencing the previous term. Okay. So for this first example, it says write the first 6 terms of the following sequences, and then yours doesn't say use the graph because I made that I already took it off yours. That's not supposed to be there. So we are just writing the first 6 terms of the following sequences. So if I wanted to figure out what a sub 1 is, you're going to plug 1 in to the n spots. So 1 minus 1 over 1 plus 1. What's 1 minus 1? 0. 1 plus 1 is? 2. So a sub 1 is 0. A sub 2, you're going to plug 2 into the n spots. So 2 minus 1 over 2 plus 1. What's 2 minus 1? And then 2 plus 1? A sub 3. So you're going to plug 3 into the n spots. So what is 3 minus 1?
2.
And what is 3 plus 1?
4.
And 2 divided by 4?
1.
1/2. Alright, it wants me to do 6. So I'm going to go a sub 4. So when you plug 4 in, what's 4 minus 1?
3.
3 and 4 plus 1?
5.
5. So a sub 4 is 3/5. A sub 5, let's see, 5 minus 1? 4. And then 5 plus 1?
6.
And 4 divided by 6?
2/3.
And then last one, a sub 6. So 6 minus 1?
5.
And 6 plus 1? So it's kind of a plug and chug situation. Does that make sense? Okay, so let's try example 2. All right, so on example 2, the little outside squigglies are just like another set of parentheses. So if it bothers you that they're squiggly and you would rather make them a giant parentheses, it's fine. It's the same thing. So it doesn't mean any different. All right, so we're still going to go in here and we're going to plug 1 in. So b sub 1 is going to be -1 to the first power, 2 over 1. So let's talk about this -1 to an exponent. -1 to the first power is going to be what? -1. It's still just going to be negative. -1 to the second power is going to be +1. So this guy right here is only ever going to be +1 or -1, depending on your exponent. Does that make sense? So this guy right here is just going to change your guy from being positive or negative. This guy right here is going to be the number. Does that make sense? So because it's odd, -1 to the first, that's negative, and so that answer is going to be -2. So b sub 2, the squared is going to make that positive, and then 2 divided by 2 is
1.
1. All right, so b sub 3, the 3 is going to make that negative. It's going to stay negative. And then 2/3 is going to just stay 2/3. So negative 2 over 3. B sub 4. Okay, so the 4 is going to turn that positive. And then 2 over 4 reduces to 1/2. B sub 5. So we're going to be negative, and 2/5 is going to stay 2/5. So negative 2 over 5. And last one, b sub 6. The 6 is going to make that positive, and 2 over 6 is going to reduce to 1/3. All right, so it's kind of like you're just plugging and jugging there. Okay, there is a way that you can type this in the calculator. All right, so if you don't have a calculator, go grab one. And then also, because we're going to mess with the mode here, if you're doing something else, you're going to want to clear your calculator. If you second plus 712, it will reset all your settings. But depending on what the people did in the other class. All right, so I'm going to clear it out, second plus 712, so everything's reset. All right. So what you're going to do, and I'll write the steps down on the notes paper here in a second, but what you're going to do first is you're going to go to mode, M-O-D-E. It's right next to the second button there. And then you're going to go all the way down to function, and all the way to the right it says SEQ, that stands for sequence. So it says function, parametric, polar, and then sequence. So we're going to go all the way over here, and we're going to hit enter, so it highlights on the sequence. Okay, so now these are like functions, but they're a little bit different. And so to type them in, you're still going to go to y equals, but now that we're in sequence mode, it's going to look a little different. Now, if you have the general form of a sequence, which means that you have your regular like n letter, there's no a, n minus 1, you're just going to type it in right here, and you don't need to mess with anything else. So if I'm going to type in example 3, which is the same thing as example 1, I'm going to get my fraction, and I'm going to hit n minus 1 and n plus 1. And if you notice, the n button is the same as the x button, but since you're in sequence mode, when you hit this button right here, it pops up as an n, not an x. Does that make sense? All right, so we're not going to mess with anything else. We're going to hit graph. And then you can kind of see the dots that are forming. You can change the window or zoom. Let's see, let's make that a little bit smaller. There we go. So you can kind of see it a little bit better there. There we go. So you can kind of see your dots form. It almost looks like a square root function. But, does that make sense? Okay. On the example 4 here, the calculator does not like the squiggly lines. So instead of the squigglies, you're going to just type in another parentheses, -1n, arrow off to the side, 2 to the end, parentheses, parentheses. So if I graph on this one, it kind of does this little alternating, which makes sense because remember when we were doing our numbers, we alternated between positive and negative. Oh, and then I forgot to show you, if you go to the table, it'll list the numbers. So all that manual stuff that we did on those previous examples, if you type it in the calculator and you go to the table, it will give you the list of sequences. So like this would be A1, A2, A3, A4, A5, and so on and so forth. Okay, so let's kind of write all that stuff down here. All right, right here, I was just gonna graph them. So if you were to type them in your graph, they're gonna be discrete individual points. You won't connect them with a line. Bless you. And this one kind of does something like this. All right, so calculator steps. You're gonna go to mode. You're gonna go to sequence. You're gonna go to y equals. And type sequence here. All right, so are we okay with general form typing that in? Okay. Flip over your notes. Before we move away from the calculator, I'm going to show you how to type in the recursive form. Because you also can type the recursive form in with this guy right here. We can still type that guy in. It's just a little bit different. All right, so go down here to calculator steps. All right, so with the recursive formula, it's not going to let you type in a n minus 1. What you're going to type in is u n minus 1, and I'll show you where that is. We want to use the blue u. All right, and then your u of 1 is going to be your starting number. Okay, can I move that? All right, so I'm gonna get my camera back here so I can show you, but I'm on example 5. All right, so on example 5, right here, we're gonna first start with a 2, because that's the first thing that pops up, right? All right, once you type in the 2, it has a n minus 1, which your calculator does not have that option. So what you're gonna do is you're gonna go to this blue u. It's on the number 7. So you're going to hit second 7, and that u is going to pop up. And in parentheses, you're going to do n minus 1. And that is going to tell your calculator that it wants to use the previous term. And then we have plus 3 on the outside. Is that okay so far? All right, now you have to tell your calculator what the previous term is. So on your paper, do you see where it says a sub 1?
Mm-hmm.
What does it give me as that number?
7.
7. So that's when you're going to drop down here where it says u of 1, and you're going to type 7. Hypothetically, if it gave you u of 5 instead of u of 1, you would change that min there to be a 5, and you see how that would pop up there as a 5? Right? Or, for example, if it made it a 0, you would change that to be a 0, and then it would pop that guy there to be a 0. But in my case, it's telling me 1, so I'm going to change that back to a 1. We're not going to use the u of 2, and we're not going to have multi-sequences that we're going to graph or anything like that. So those are kind of the 2 ways that you're going to be graphing sequences in the calculator. You could hit graph, or on this one here, we can just go to the table, and so it's going to give me my list. This is A1, A2, A3, A4, A5, A6, and so on and so forth. Does that make sense? Okay, so I think I'm done flipping. All right, so because we typed that one in the calculator here, let's just list, and then we will do example 6 by hand. So A1 is 7. From the calculator, A2 is 17, A3 is 37, A4 is 77, and A5 is 157. All right, so what this looked like in the calculator was 2u n minus 1 plus 3. And then u of 1 was 7. All right, so that's what it looks like in the calculator when you type it in. And then you just have to go to the table and you get all your numbers. Okay, so on example 6, and we're just doing the first 5 terms. Just like we did before, we're going to find the first 5 terms. Now, a of 1 is easy because it gives it to me. It's -5. A of 2, we have to plug 2 in to the end spot. So you're going to get A2 minus 1 plus 10. All right, 2 minus 1 is A1. And so that's why it's always going to use the previous term. Because I know that A1 is the same thing as what? -5. So -5 plus 10 is 5. So A sub 2 is going to be 5. All right. So A sub 3 is going to use the previous term, which is A2 plus 10. And what was A2? 5 plus 10. So A3 is going to be 15. A4 is going to use the previous term plus 10. And the previous term was 15, so A4 is going to be 25. A6 is going to use the previous term plus 10. And, oh wait, no, not A6. Sorry, I totally skipped A5. I don't even need A6. A5 is going to use the previous term, A4 plus 10. And I know that A4 is 25, so then A5 is going to be 35. All right, so that's how they're different. So recursive uses the previous term as a reference, and then the general form, you're just plugging in for the n number. Okay. So, and we're going to get more into the patterns and creating a sequence later on, but for right now, because all we've done is the adding and subtracting, that's what we're going to be looking for. So we are looking for the adding and subtracting patterns to relate the consecutive terms. So on this one, 1, 4, 7, 10, 13, what are we adding by every time? 3. So these guys here are going up by 3. So we are going to start with our starting number. What will we say our starting value is? 1. It's the very, very first number. And so then I'm going to say my sequence is going to be a n minus 1 plus 3. The previous term plus 3. So I have my starting number, previous term plus 3. So that's the recursive formula. All right, what about on 8? What are you switching by? Minus 5. All right, so I'm going to say my starting number is going to be 4. And so my sequence is going to be a n minus 1 minus 5, because we are minusing 5 every time. We will get into the more complicated formulas, but for right now, we're going to keep it easy until we talk a little bit more about some other things. All right, last thing that we are going to talk about today is factorial notation. So if n is a positive integer, the notation n with an exclamation mark is read as n factorial. So n factorial is the product of all positive integers from n down through 1. So for example, if I had 5 factorial, that's 5 times 4 times 3 times 2 times 1. 0 factorial is 1, not 0. That's a common misconception. And I am going to show you how to simplify this by hand, but there is a factorial button in your calculator. Is there a shortcut? Let me see. Nope, I don't think I see a shortcut. Okay, so you're going to hit math. You are going to scroll all the way to probability. And it's number 4. Y'all see it? I lied about this. All right, so. All right, so if you hit math, go all the way over here to probability, and then you see the little exclamation point right there. Okay. Oops. All right, so it says find the values for n factorial, and we're going to do this without a calculator right now, just so you can get the idea of what a factorial does. So 1 factorial is going to just be 1, because 1 is just 1. 2 factorial is going to be 2 times 1, which is still just 2. 3 factorial, 3 times 2 times 1, which is 6, right? 3 times 2, 1. All right, and then 4 factorial, which is 4 times 3 times 2 times 1, which would be 24.
How many do you have to do? Just as many as there are in the
This,
number.
yeah.
No.
Most of the time it won't ask you.
Oh.
So
Oh.
the reason why we talk about factorials is because you will see them in sequences and series. It's just one of the symbols that's a lot of times used. So we're just going to treat this factorial like we know how to evaluate. And then remember, if you had a calculator, you could plug that factorial sign in when you type your sequence and series in the calculator. But we're going to do this 1 to 4. So a sub 1. So we're plugging 1 in for all the n spots. So what is 2 to the first power?
2.
2. What's 1 minus 1? 0. What's 0 factorial? 1. So that's just going to end up being 2. Okay, so now we're going to do a sub 2. So what's 2 squared? 4. What's 2 minus 1? 1. What's 1 factorial? 1. So that's going to just be 4. Okay, a sub 3. What is 2 cubed? 8. And what's 3 minus 1? 2. What's 2 factorial? 2. And so 8 divided by 2 is 4. And then the last one, a sub 4. So what's 2 to the 4th power? 16. And then 4 minus 1, which is 3 factorial, which is 6. And 16 divided by 6 is 8 over 3. Without a calculator, you're not going to have to do much more than 4 factorial. But there is a way that we can simplify factorial expressions without a calculator with these big numbers. All right, so I'm not going to want to do what 12 factorial is. That's kind of crazy. All right, so let's think about this. 12 factorial is 12 times 11 times 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. 2 times 1, that's 2 factorial. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And that's 10 factorial, right? All right, what do you notice is canceling? Yeah, the 10 and then everything else. Does that make sense? Because everything's being multiplied. So 10s, 9s, 8s, 7s, like that's all going to reduce. So these are all going to reduce. And then you could, if you wanted to reduce farther, what's 12 divided by 2? 6. And then 6 times 11, 66. Now, normally, I'm not going to write all of the numbers. Normally, what I would do is I would take this 12 here, and I would go 12 times 12 times 11 times 10, and I would just end that as 10 factorial. Instead of writing 10, 9, 8, 7, 6. I would stop until it matches what I have on the bottom. And I know that these guys are going to end up canceling because it's the same thing. It's going to be 10, 9, 8, 7, 6 on top and bottom. So it will all cancel. Does that kind of make sense? So normally this is the work I would do, not this. But I just wanted to show you why 10 factorial will cancel out. Because it's going to end up being the same numbers being multiplied. Okay, so let's look at it without maybe numbers and you have letters. All right, it's still kind of the same concept. I want to get this n factorial, I want that to cancel. All right, so if I'm going to kind of write out n plus 2 factorial, I'm starting with n plus 2, and I need to go down 1. So when you go down 1, that's n plus 1. Now when you go down 1 from n plus 1, that's just n. And I'm going to stop there, and I'm going to say factorial. Because this technically goes on all the way down to 1, right? n minus 1, n minus 2, n minus 3. We just don't know what n is. But it's going to go all the way down to where it hits 1. But what I do know is that I'm going to stop at n because it's going to end up canceling with this n on the bottom. So those factorials will cancel. And I'm left with n plus 2, n plus 1. All right, so you can simplify factorials with letters as well. Just remember factorials will just decrease by 1 and you're just multiplying everything. All right, make sense? Okay, for your homework. All right, the first 4 right here, you are writing the first 5 terms of the sequence. Practice doing it without a calculator just so you can get the idea. But if you want to check your work with the calculator, you can. The next 4 here, you are finding the nth term of the sequence from the given pattern. So looking for the adding and subtracting patterns. Then you have recursively defined sequences. You are still writing the first 5 terms. All right. You can practice typing it in the calculator to check your work, but I would do it both ways. All right. It's kind of practice finding the terms by hand and in the calculator. Then the next 4 here, you are just evaluating the factorial expression by simplifying. And then the last one is a word problem, and it is meant to do in the calculator. Do not try to do it by hand. You're going to type that guy in the calculator. All right, so you're going to type this function here, this sequence, in the calculator, and then answer the questions. Sound good?